the work here. Yeah. Picture. So this is the result we have, right? And now they ask us to report the result in the question form, right? Along to the number of observation and R square. It is similar, right? So here we have the here we have the dependent variable is sleep, right? Sleep here, yeah. And then we have the constant because here we only want independent variable, right? We have the constant here, 6, 7, 3, 3. Okay. And then we have the coefficient on the total work, right? This is 0, 1, 5, 0, 7, and this is total work here, right? Yeah. And so we have two variables, right? Sleep and the total work. Yeah. And the coefficient and the beta 0 here. And we have the standard errors for the constant and the standard error for the total work. The constant. Yeah. And the standard errors for the total work. Yeah. And here we have the number observation. And R square here it is 10.3%. Yeah. So this way we report the estimation result. Yeah. And they ask us what does the intercept in this equation mean? Yeah. So what is the intercept, right? What is the intercept for the what is the meaning of constant here? So the meaning, what is the meaning of constant?
It is decrease. Is it decrease? I mean, like, hold on. Let me find it again.
So
Um,
the
a
meaning
negative
of
significant
constant.
impact.
No, the meaning of constant. The constant. That's mean the meaning is this. Okay, with line.
I think that is the value of the dependent variable when the independent variable equals 0.
Yeah. Okay. Yeah. Because here the total work here, the total minutes for working. That's mean, right? If the total minutes for working equal to 0, that's mean suppose that you have no work, right? Suppose you have no work. So the time for sleeping of you it is this one. Yeah. So if the total working during the week here equal to 0, that's suppose we have no work, right? Yeah, the total minutes work per week, right, equals 0. Sorry, the time sleeping time here, equal to the constant. Yeah, because we know that the meanings of constant here. This is the value of dependent variable when on independent variable, right, equal to 0. That's mean here, because here we only have one independent variable, right? That means the total minutes work during the week equals 0, right? Suppose you have no work, right? The time, sleeping time, yeah, yeah. And number 2, so based on this model, if the total work increases by 2 hours, right? 2 hours, how much is sleep estimated to fall? Yeah. So the last, so we don't need to confirm whether last or not last. Yeah. So 2 hours. So here, how to do the B? So if the total increases by 2 hours, how much is sleep is estimated to be fall? Yeah, you see. Okay, Gia Long. Gia Long no. Hữu Hùng.
Right, right.
Okay.
When I'm thinking back.
So here we have
Mhm.
the if the
So
independent variable is raised by 2 hours, right? So the how it influence the dependent variable.
so I think it equal the constant plus the plus uh, the constant plus two multiple for the coefficients of total work. Is it right?
No, because here we would like to see whether the total increased by 2 hours. 2 hours, that means we have 120 minutes, right? Because our unit for the total work is the minutes, right here, the minutes here. Yeah, so this will lead to if the S is read, right, 2 hours, right, mean 120 minutes, right? And the sleep will increase by, so we have the coefficient of the total work here. Yeah, the coefficient of the total work here. And now, right, we know that the coefficient in total work will indicate, right, the effect on the sleep if the total work increased by 1 unit, right? But now the total work here increased by 120 units, right? That means we have the values here, right? You see the sleeping will fall 120, and this is the result. Yeah. Right. Right. Is mm. Okay, you can calculate by yourself, right? So the coefficient on the total work here will indicate, right? So 1 unit increase in the total work will decrease, right? The 0.150 107, right? Units in the sleeping time. But now the total increased by 2 hours, right? That means so we have the effect here. Yeah. And day. So find the effective value or relative value of sleep if the total minutes work during the week equal to one. Okay, 1 minute is very small, so I think we can change to 100. Yeah, 100 because one is very small. Yeah, so 100, and it's easier for us to calculate. Right here, we have they ask us to calculate the relative value of sleep if the total minutes work during the week equal to 100, right, minutes. But we know that we use the total work to get the to reduce the sleep here, right? So here they ask us to calculate, right? So we just have here sleep, right? And now we have the constant and the total work. Now we have it is 100. Yeah, and we can get a result. Yeah. So any question here, ABC? And they ask us to include male into the model as an additional variable. That means original we have the total work as the independent variables, right? And now we have the they ask us to include in male as additional variable and re-estimate the model and explain the coefficient on male, right? So here we have the no, the result we have, the data we have, right? Sleep, the total work, and meal, right? So now we re-estimate the model, right, by add one more independent variable, right? So for the independent variable now, we have the total work and the meal. Yeah, we choose this one. Yeah. So we choose the independent variable, right? And then we including intercept here. So this will lead to here we have the new result. Yeah, this is the result we have, right? So we can copy this result to the mega slide here, or from the Excel here, right? And now they ask us to report the right re-estimate model and explain the coefficient on mail, right? Explain the coefficient on mail. Suppose here we have the mail here, easy. So now because we have the new independent variable, right? This will lead to the constant here also change 3.044, and we minus 1.682, and total work list loss 8.84. Yeah, mail. And here we have the constant. Yeah, and the total work here you have. Yeah, and the mail here you have. Yeah, okay. And the number of observation still here, but because here we read the new independent variable, right? The R square here it reads to 11.2. Yeah. Okay, here. So and they ask us to explain the coefficient on mail, right? Explain the coefficient on mail. So how to interact the coefficient on mail? How to interact coefficient on mail? We define mail here is a dummy variable. We define mail here is a dummy variable, right? That equal 1 if a person, right, is male, and 0 otherwise. Yeah, otherwise here. Yeah, otherwise here. So and now how to explain that this is a dummy variable, right? How to interact the coefficient here? So what is the main roof?
The male group, right?
Yeah, the main group is the male, right? And base group is the female, right? So the coefficient on the dummy variable here will compare the sleeping time between male and female, right? So here we have the positive coefficient. That means male here sleep more than female, right? By 88.84, right? But because it is multiple regression model, right? We say holding on other variables, right? Constant, right? So the male sleep more than male by this one. Yeah. So this way we explain the coefficient, right? This is the coefficient on female, right? So we compare the outcome, and the outcome here is its sleeping time, right? Sleeping time between male and female, right? But we have the positive correlation, right? That means male sleep more than female by. Yeah. So any question here? Yeah.
Dạ thầy ơi, cái khúc đầu em bị mix cái chỗ mà thầy add cái mail vào cái data, thầy làm lại em để ra lại cái bảng. Dạ.
Ok. Thì mình chọn mình hay gì mình chọn total work thì mình chọn cái hai thôi. Ví dụ như đây mình chọn bình thường đúng không? Hay gì bình thường mình chỉ chọn independent của mình là biến cái chỗ total work thôi, thì giờ mình chọn nè total work
Dạ,
là
dạ.
nêu luôn.
Dạ.
Mình quét vậy thôi.
Dạ.
Vậy sao em muốn chọn 3 cái em quét 3 cái.
Dạ.
Okay, here and then we can explain the meaning of R square or adjusted R square. Yeah, R square, adjusted R square. So adjusted R square is useful when we compare two model, but for one model, either you can use R square or adjusted R square. It is okay. Yeah. So here, we can explain. So what is the meaning of R square here? So the R square, right? The R square we indicate, for example, R square equal to 10%. Right? That's mean the S can explain the 10% total variation in Y. Right? But here we have the two independent variable, right? That's mean the total, right? The total work here and the total work and male here, right? Can explain, right? 11.2% total variation, right? In sleeping time. Yeah, yeah. So this is the dependent variable, and we have two independent variables, right? The R square here indicate, right? We indicate that the variation in the dependent variable can be explained by the all independent variables, yeah, or regression. And the last one. So they asked us, right? They also estimated, right, the equation and got the estimated result, right? And in this equation, right, you can see here we still have the effective value of sleeping time, right? But now they add the total work, right? They add the education level and they add the age, right? The age. And now they would like to test whether the education level has a significant or the has a significant impact on sleeping time, or age had a significant impact on sleeping time or not, right? And they note that the standard errors, right, along with the estimate. That's mean here we have the copy intercept, we have the coefficient, and this is the standard errors for the constant, the standard errors for the total work here, here, right? And now they ask us to test whether here at 5% significant level. Again, two-side test, right? The education and age has a significant impact or not, right? So we would like to test here whether the coefficient, right? The coefficient, the coefficient on the education here, right? Equal to 0 or different from 0. Yeah. Or here, the H1 here, right? It's different from 0. Yeah, different from 0. It's significant in two sides, right? And we have the coefficient, right? And we have the uh standard errors, right? We can calculate the t, right? And at 5% significant level equal to 5%, right? That means we have the critical values for the two-side test equal to 1.96, because here the number of observation is very large, right? 706. So it's very large, so we can use normal distribution. Yeah. And because they provide a question, right? We do not have the b-value, right? So we need to use the critical value. But in this situation, we have b-value. We use b-value, it is easier, right? But in this situation, we do not have the b-value. We need to calculate the critical value and t statistics, right? And the test statistics here, we have, because we use normal, right? We have z here equal to the coefficient we would like to test is in the education, it's a minus, right? Minus 11.40 divide and minus the value you would like to test, but the value you would like to test here is 0, right? And divide the standard errors. It is standard errors, right? 5.88, and you have the result. Let me see. Yeah, so it is result. Right, the result we have here. And at 5% significant level, right, we can say that the absolute value of z here, right, is smaller than absolute value of smaller than the critical value. All right, so this would lead to we fail to reject the null hypothesis. Fail to reject the null hypothesis, right? That's mean. So what mean here? If we fail to reject the null hypothesis, that means
There's no sufficient.
So in now we would like to test whether this is significant or not. So if we fail to reject the null hypothesis, that means the
Insignificant.
yeah the impact of education, right, on the sleeping time here, right, is not or insignificant. Is statistically insignificant at it we choose 5%. Oh, okay, they have the 5% significant level, right? So if we reject, that means the coefficient is different from zero. That means significant here, right? But here we fail to reject. That means the coefficient here may low is very low to zero. That means the insignificant. Yeah. So in definition, that means it's actually no relationship between the education and sleeping time. Yeah. In this situation. Yeah. So any question here?
Thầy ơi, em không hiểu cái chỗ câu E tại sao thầy lại kết luận là total work với lại meal. Ý là em không hiểu cái chỗ đó thầy.
Okay. So what is the meaning of R square? The meaning of R square. The R square. Let me see. No. Yeah, you can see here for the multiple regression model, R square is interaction of sample variation in Y. That is explained by independent variables, right? For the simple regression model, we only have one independent variable. That's when we say, right, S can explain, for example, R square here, right, equal to 10%. That means for the simple regression model, right, S can explain 10% of 10% the total variations in Y, right? Because in the simple regression model, we only have one, right? One independent variable. That means the S. But here we have many independent variable, right? Many independent variable. This would lead to R square here, right? For the multiple regression model equal to 15%, right? That means here we have S1, S2, S3, yeah, can explain for some 50% total variations, right, in Y. Yeah, variation in Y, right? Because here we have many. We use the S1, S2, and S3 to explain Y. And in this iteration, right, three variable only explain 15% of total variation in Y. And actually, we have there are many variables may include Y, but we do not include in the model. But in this model, right, S1, S2, and S3 only account for 15%. And similar here, we have in this model, right? In this model, we have two independent variables. We use the total work here, and we have male here to explain the sleeping time, right? The sleeping time. And in this model, we have R squared equal to 11.2%. Yeah, 0.2%. This will lead to, right, the S1 here, we have the total work, right? The first independent variable. And S2 it is male, right? That means we use total work and male to explain the sleeping time. And you can see here, two independent variables only explain 11.2 the total variation in the sleeping time. That means the dependent variable here. Yeah, and actually there's so many variables may influence, right? Can explain the sleeping time, right? For so many variables, for example, the hobby or the sport or something. Yeah, and job type job or something. Yeah, so we cannot, but we do not include in the model, right? In our model we only include the total and male, and two variable only account for 11.2%. Yeah.
Yeah, I got it.
And yeah, similar, so any question? And so this is the way we test for the education, and similar for the age, right? And we also test for the age here, right? So we would like to say whether the coefficient here equal to 0 or different from 0. Yeah, because he would like to test whether it's significant or not significant, right? Significant, that's mean different from 0. Yeah, sometimes they also ask us to test whether this coefficient is larger than 1 or larger than or smaller than the -1 or something. Yeah, but if they just ask us to test a significant, right? That means we test whether it equals to 0 or different from 0. And actually, we do not care whether it is positive or negative. Yeah. So, and here we have the significant level to 5%, right? Critical value to here. And now we have the coefficient. We would like to test here it is 2.2, right? Minus, right? The coefficient, the sample coefficient. And the value we would like to test here is 0, right? And divide the standard errors of the coefficient 1.45, right? And here we have the result is the yeah. So this is the result we have. Yeah, and similar here, right? So we have the z smaller than reachable value, right? So it's a fail to reject the null hypothesis. That means we have the impact of age here, right? On the sleeping time is statistically significant. Yeah, so this way we test the hypothesis because it is not significant, right? We no need to interact the coefficient whether one unit is into something. Yeah. So any question here? So any question here? Okay. If not, we can finish this session today and tomorrow, right? We still have one last session, and in that session, I will introduce shortly the two sample hypothesis test, right? I think it is only the 30 minutes, right, to introduce that session. Yeah. And after that, we go for review, right? I may, yeah, I will show you the structure of the final exam test, right? And uh, some exercise. Yeah. Okay, any question here?
Thầy cho em hỏi là khi mà nó kêu interpret cái significance thì mình sẽ suy ra kiểu là statistically significant or not. Còn ví dụ như mà nó còn yêu cầu interpret cái coefficient thì mình mới kiểu là increase hay decrease bao nhiêu thì nó sẽ kéo theo cái kia này.
Đúng rồi.
Dạ.
So any question? Okay, if not, see you tomorrow. Yeah, thank you.
Dạ chào thầy.
Em chào thầy.
Dạ em chào thầy. Em chào thầy.